Here is my quick overview of how to use the CalcPlot 3D to graph your regions for a solid of revolution. So when you go to CalcPlot 3D, it kind of starts at this default graph, which is a really nice 3D graph if you have to take Math 254. This will be a great resource because it does a nice job of graphing 3D graphs, but we don't need that right now. So we can hit the little X and get that to disappear. So that'll clear our 3D axis here. And so we are going to add to graph. So we're going to hit that little add to graph menu, and we want the one at the very bottom, which is the surface of revolution. So it's kind of starting us here with a default one with square root of x and x squared, where square root of x is the top function, x squared is the bottom function. But let's change that just a little bit. Let's just look at x squared, oops, as the top function, and then the bottom function as just y equals 0. So when you change things in CalcPlot 3D, if you notice, oops, you can move around your graph, but if you notice your graph doesn't change what functions are on there until you actually hit enter on one of them, and then it'll change that actual graph. So now I've got a new region. What's nice about this is up at the top, you see a 2D picture of your region, and then you have that 2D region kind of superimposed in that 3D graph. And I think we'll look at this from 1 to 2. So again, I have to hit enter or return. Now I'm noticing it's going off my scale because my y-axis is only going to 2. So if I want to change my y-axis, I need to hit right after that little 3D mode. There's a little box there. It's kind of gray and blue. That will bring up this format access. And let's see, maybe we'll just go a little further out on the x-axis and just to see a little bit more. We don't need to go more backwards. And let's go to 5 on the y-axis. I'm also going to need to go to -5. Oops. On the y-axis because we're going to rotate this around the x-axis. So I want to be able to see the whole picture. I want to see what's happening when I rotate it and it goes underneath the x-axis. So now that I've got all of this figured out, my scale, and then I can again see my 2D picture there, I can come down here onto the slider and have it rotate my region for me. And so it'll rotate that region and show you what your graph looks like in 3D. So if you can kind of look at it if it's only part of the way. You can also saw me this before. If you click on the image itself, you can get it to move around like that. Another thing that you can do with this is if you would like to see that sort of one representative rectangle on your graph, and you can pick the x value where it goes, you can slide it around. So this is the idea that we're taking some kind of random rectangle in this region, and then you can hit rotate, and oh, actually you can get it to, if I do this, I can just rotate that one representative rectangle, and then we can see that actually it's a circle, it's a disc. So we can get that visual of, oh, that's our disk. So we can unclick that. We could also take a look at if we had this as a Riemann sum, what would this look like? Let's grab a few more of those rectangles. So this is us chopping it up into 11 rectangles. And now we want to hit the revolve the washers. And it'll revolve those around for us and show us what it looks like if we revolve just those chopped up discs for our Riemann sum. So let's take that off. So then you can also use this to graph between two functions. So like it had when we first looked at this. So if instead of the y or x-axis there, I wanted to use the line 1/2 x to be my lower bound. So then I can hit return. So now you can see that changes my region, and up in 2D picture, you can see the line that we have. We can see our quadratic. In the 3D graph, it's just going to give that region. And then we can, again, hit that rotate and see that we're going to get a 3D figure that has a hole in it. It's got basically a hole that's a cone. And so it's the same region we had before with a cone cut out of the middle is the idea of what we have here. And then you can also go down below and change from y equals f of x to x equals f of y. So this is if we have our functions defined in terms of y instead of in terms of x. So they give us, again, a region here. I'm going to erase this one and say, well, what if we had y squared, y enter. Ooh, I think I've got to put some sort of lower bound on it. There we go. Um, and it's going from y being -1 to 1, so maybe we want it to go from 0 to 1. And then if we were going to, oh, my scale is a little big on this. So let's change this. Let's change this from -2 to 2 and -2 to 2, kind of back to the default. Hit enter. So then we can see our region, and it is rotating around the y-axis. Oh, this is rotating around the x-axis. If we want it to rotate around the y-axis, we have to do x equals 0. Hit enter again. Anytime you want to change something, you can rotate that around the x-axis. So that's just a little overview of how to use this program. Again, anytime with this, you can put that representative rectangle on there. You can, have that rotated around so you can see how that disk rotates around, or you can have it do that Riemann sum. But it's just a nice way to help you visualize what's going on with these regions and what that volume looks like when you rotate it around.